Probably the most commonly used data type in most SQL Server installations is going to be exact numerics when we're talking about storing numbers. And so let's go through and talk about the numeric data types. There's a family of them, and you have quite a bit to choose from here, but your choices really are based on a couple of things, and that really comes down to size and scale. So let's start off and just go through them. Big integer, B-I-G-I-N-T. You use this guy when you have really large numbers that you want to store. And notice this takes up 8 bytes of memory to store every number when you put it in. So, if you have 1,000 numbers in there and you use the big integer, then you're using 8,000 bytes of memory to store those things. Notice the number size. I'm not going to try to read that to you. It's from that large number negative all the way through that large number positive. I used to know what that number is, but as you can see, you can probably take care of your payroll and your expenses and that sort of thing with that kind of number. Now, there's integer, int, and this is probably the most standard data type that's used for numbers in SQL Server. This generally is a good idea, but a lot of times it kind of shows laziness on the part of the developer because we just get used to putting int in the data types. Notice it uses 4 bytes of storage. It will allow you to store numbers that range from negative 2,147,000,000 and some change there, you see, to positive 2,147,000,000 and some change. The next data type is the small integer, and small integers used quite a bit by a lot of people. They've at least thought this far out, and that is a 2-byte storage data type, and this will allow you to store from negative 32,768 through positive 32,767. So you see right here on this one slide, you've got 3 data types that based on the application and the data that you're trying to store in that particular field, you have quite a range to choose here. And if you can get by, if you're never going to store less than 32,768 or more than 32,767, you should use a small integer instead of an integer, and certainly instead of a big integer. Let's continue on now. Let's talk about the tiny integer, tiny int. This uses 1 byte of storage space, and it will store numbers from 0 to 255. Notice no negatives, just from 0 to 255. Then we have a decimal data type. Now, decimals introduce the idea of precision, and we can have a decimal be from 5 to 17 bytes of precision, and you'll notice that when you create a decimal data type, you can tell it the precision and the scale, and so you will put numbers in here for precision and scale. Now the P stands for the total digits stored. So if I say decimal 10, that means I can store up to 10 total digits here. And then on the scale, this is the number, how many of those 10 digits that I want to store to the right side of the decimal. So as you can see, I can easily tweak this thing for the amount of precision that I want. So if I need 6 decimal places, then I just need to figure out if I got 6 there and I need 4 on the left side of the decimal. So this would be a 10 and 6. So decimal will let you choose, and obviously based on how much precision and scale that you put in there, it's going to use more bytes to store it. Money uses 8 bytes, and the money data type will store from negative 922, whatever that number is, to a positive 922, whatever that number is. Large number, lots of room there. Small money, 4 bytes of storage, and it will store from 214,748.3648 to a positive 214,748.3647. Now keep in mind again, with these exact numerics, you can always get back exactly what you put in. You can always get the same result no matter what processor you're running on and so forth. Next data type is a bit, and the storage on a bit is kind of interesting because a bit really is just 1 byte, and we're going to store a 0 or a 1, and then we're going to later go back and we can convert those into yes, no's, true, falses, whatever in our code. But understand that when I first say I want to use a bit data type, SQL sets aside 8 bytes for that. And then all the way up to 8 columns of bit data types in my database, it will continue to use that same data type memory space, if you will. So what that means in English is that if I have 8 or less bit columns, they're all stored in 1 byte. As soon as I add that 9th bit column data type in there, then it goes to 2 bytes. And so it reserves memory for these 8 bytes at a time. But notice what's cool about that, I can store 8 columns worth of bit data in 8 bytes of storage space. And so that's pretty cool. Now, the usage guidelines on Exact Numerics is very straightforward. You always want to use the smallest data type that will give you the ability to store up to the largest possible number that you're going to need to store. That's just going to save on your database size. It's also going to make your searches faster. There's less stuff SQL has to look through and so forth. So that's your Exact Numerics. You need to familiarize yourself with those and be ready to choose the appropriate one in the most efficient manner as you develop your databases.